There are many crafty ways that malicious users can force the execution of malicious code on machines. In this video, we'll discuss cross-site scripting. A cross-site scripting attack begins in step 1 with an attacker injecting some kind of script code into a trusted website. Now this normally happens, for instance, through a field on a web form that isn't properly validated. In other words, it might allow the user to input anything before the data gets saved and uploaded to the server. Now, usually what the attacker is doing is they're injecting their malicious code into server-side scripts. In step 2, an unsuspecting user of that same site then executes the script. In step 3, the script is now running on the unsuspecting user's computer locally in their browser and could potentially access their cookies in their web browser or other session details. Most modern web browsers are sandboxed, which means that anything running in the context of that web app will not affect outside of that web application. They can't talk to the operating system kernel and so on. But it depends on the version of the web browser in use on the client device and how it's configured. Cross-site scripting is often simply referred to as XSS. So what can we do about it? Well, some countermeasures include filtering inputs. So we want to make sure that developers are following secure coding guidelines and that they are carefully validating every field on a web form or even validating URL strings sent to a server to be parsed to make sure that only acceptable data exists. As always, user awareness training is also very crucial so that if a user notices some kind of suspicious activity or behavior in their browser, they should generally be aware that maybe something's up. There could be some kind of a cross-site scripting attack taking place. In other cases, cross-site scripting attacks execute code on a client machine in the background where there may not be any visual indicator, at least at the time of the attack. Another type of attack is a cross-site request forgery, which is often referred to as a CSRF. In this type of attack, code gets executed for a user that's already authenticated to a web service. Now that code is executed by an attacker, not by the user. The user doesn't know about it. So one way this could happen is an attacker to compromise a user system and then have the ability to send a user authentication token that's been modified by the attacker to the web app. Now this can be done by the attacker making changes to or perhaps modifying and sending off a web browser cookie to a web app that already trusts that there is an established session in place. So the attacker then could transmit instructions to the server without user consent. This could also take the form of a URL that the user is tricked into clicking on, maybe to transfer funds to a different account at a different banking institution, and so on. There are countermeasures that we can apply here to mitigate the effect of cross-site request forgeries. First of all, the web application server-side can ensure that requests came from the original session. There are many techniques that usually developers would put in place due to security coding guidelines to make this happen. Now, one would be to check the origin header in the HTTP request to make sure that it's valid and matches the site, or to use some kind of a challenge token that's unique to each session, or to use some kind of a randomized hidden cookie value that gets checked every time the cookie is sent to the server. Users, of course, should not leave authenticated sessions open. So, for example, if a user is working with their email online or working with online banking, as soon as they're finished with it, they should log out and not wait for the timeout to occur. At the same time, users should never save passwords for web applications. In this video, we talked about cross-site scripting.